Hello, it's Cliff here. In this video I'm going to be going into the Hallmark lathe tool setter, the LTS-M, the mechanical lathe tool setter. If you've stumbled on this video and you haven't seen the introduction video to the new range of tool setters from Hallmark, it would be worth seeing that first so that you can see what this is in context. Have a look at the general video first, introducing the three different tool setters. This is going to be specifically just about the LTS-M. As mentioned in the introduction video, when I was manufacturing the pilot production run of this LTS-E electronic tool setter, although it's a really brilliant tool setter, I began to realize there's a lot of work in it, a lot of complexity, and it might not meet the budget of a lot of people looking for a tool setter, especially if you're just looking for a tool setter that you want to use manually. And so I developed this LTS-M lathe tool setter mechanical, and it uses a dial indicator to register movement in the X and the Z. It has some advantages over the LTS-E, and it also has some disadvantages. I'll go into it deeply in this video. So to start with, let's just look at the bare bones of it. I'm going to get used to this camera operating above me. It's all back to front. So first of all, there's a cylindrically ground body, which is a 3/4 inch shank. It's of hardened tool steel, tempered and cylindrically ground, high precision shank, and ground between centers, and an anvil that slides in it and also pivots out of it, hardened and tempered tool steel and surface ground. And hopefully you can see it has a lot of travel in the Z, and it pivots away in the X and has even more travel in the X. And a dial indicator goes through the middle of it and links to the anvil and registers movement. So there's two springs that pull it back against a precision stop so that it always returns to the same position. And the advantage of this type of tool setter is that you're using existing mass-produced low-cost technology of dial indicators, needle type or lever type dial indicators, and I picked up a bunch of them through AliExpress from China. Whether or not I supply them long term is unclear at this stage. It's probably going to be cheaper for users to buy them themselves. I can give the specifications. It's a very common specification of dial indicator, but to make sure it fits, I will put forward a few different models that you can choose from. So it's a very reasonable piece of equipment, the mass-produced dial indicator that replaces a lot of the expensive technology in the electronic tool setter. And it's highly accurate. And one advantage of a dial indicator is that it's not just an on-off position, but it sweeps past a 0 point, and so you can see the anvil being contacted by the tool and then sweeping past a certain point which represents, for example, X0 or Z0. So you can see it coming, you can see when you're on the button, and you can enter that 0 into the tool offsets tool touch facility, and you can see when you've gone too far. So a dial indicator has some advantages over an electronic tool setter. It took quite a bit of developing to get it as repeatable and accurate as it now is. Let's see if I can show you how repeatable it is. So I'll swing the X-axis movement, and you watch how it returns back to 0 every time. And at the same time, I can press on the end and see how it returns back to 0 every time. Now that took a lot of refining and a lot of work. It wouldn't be possible to just copy what you can see here in this video, come up with a rough copy of it and end up with as accurate a tool setter. there's a lot of very key subtle points that I had to learn the hard way before I could get this tool setter to be as accurate as it is. I've been looking into different types of dial indicators that would suit, and it seems to be the biggest quantity and best price dial indicator format is this range put out by Swiss Gyrotest, Mitutoyo, and some Chinese, probably copies that are quite good quality, Shahi and Syntec. And these two Chinese alternatives are quite good value for money and seem to be quite well made. So if you were to purchase your own dial indicator for this lathe tool setter, you'd need to be careful to get it of that approximate specification. There is some flexibility within the mounting, the clearance, and the stylus contact position to take different size dial indicators, but seriously different size and shape dial indicators, it won't accommodate every single type. So we need to double check that the right dial indicator is connected to this lathe setter. It would be simpler if Hallmark Design were to import these and fit them onto the lathe tool setter, so you know you've got one that fits, but obviously that's not going to be the cheapest option because you've got a lot more handling and freight, and it would be cheaper for the end user to buy it directly and therefore get the manufacturer's warranty and so on. So that's something we need to work out over time. But initially I've bought in several samples and I can supply some to a user that's looking for hasn't got the time to get involved in purchasing their own dial indicator. So the big advantage of having a low-cost, mass-produced dial indicator like the Shahi or the Syntec is that we're getting a lot of precision technology for a very low price. We can capitalize on that and get a very precision lathe tool setter going at a much better price than the electronic tool setter. So what we're looking at here is a much more affordable lathe tool setter. If you're interested in price and availability, please don't ask in the comments below the video, because the video is best to be kept for technical questions and information. Commercial matters like price and availability change over time and need to be in an edited format, for example on a website or by email. So have a look in the Hallmark Design website for information on price and availability. It should be there soon. If it's not there already, you can go to contact and send me an email. So we're looking at a lower cost option here, and I'm trying to think of ways to keep the price down. So you could just buy the bare bones unit, and rather than also purchasing the level index plate, you might already have a bevel box, which is a digital index plate effectively with a magnet on it, and you could stick that on the chuck on your lathe. So, you know, the very cheapest option would be just to buy the bare bones tool setter and your own separate dial indicator. And you could make your own level index plate or use something like a bevel box. Alright, let's discuss the LTS-M on the machine now. We'll put it on Slant Pro. I think you saw on the introduction video how you set up or calibrate the anvil parallel with the x-axis by traversing a dial indicator. Then we set the index plate with the bubble in the middle vial in the middle. Be careful not to bump the camera. Okay, now that's set, and every time it's just set the once, and every time it's reinstalled in the machine, it can be quickly orientated. But it's important that the tool setter is concentric, held in the collet or chuck, and with Slant Pro that's not an easy thing to achieve, because the 5C insert that holds the 5C collet can very easily be installed incorrectly with some dirt or burr or pressed in unevenly, so that or even have an error so that the 5C collet is not running true. So you'll soon find out about it if you put a dial indicator on the end of your tool setter and rotate it, because this end portion beyond the dial indicator is cylindrically ground between centers parallel to the whole length of the body. So it's a very good way to check that you've got your tool setter set. You need to have an accurate collet or adjustable 3-jaw chuck that's floating on its back plate so that you can do accurate work anyway, and this just exposes whether or not you've achieved that. So you can check that it's concentric there. I've got it reasonably good on this lathe. That's about 2/100ths of a millimeter total run out. You're getting 3/4 of a turn there. That's enough to check that it's concentric. That's about 1/100th of a millimeter off center at that point, projected out from the end of the spindle nose. That's about, a bit less than half a thou out. It would be better if it was closer than that, but realistically on these low cost lathes it's difficult to achieve precision, extremely high precision. Actually, a 3-jaw chuck floating on its back plate can be dialed in much more closely than that. But I'm just using a 5C collet for this demonstration because it's streamlined for the video, and I know a lot of people use 5C collets. Well, one of the advantages of a dial indicator type tool setter is that the needle sweeps before, through 0 and past 0 and gives you a good reference for where your tool is. One of the disadvantages is that it can be a little bit more difficult to see. You need to either crane your head inside the lathe when you're making the setting, if it's a precision setting, or use something like a mirror, a magnifying mirror or a mirror, or try and estimate the parallax error. If it's not critical, if it's just a drill or a parting tool or a roughing tool, the parallax error, viewing it from an angle won't be enough to worry about. But I'll set the camera up on a tripod that represents where your head might be when you're doing a precision setting. That might be approximately where your head would be, where the camera is. That's right in front of me, but I'll see if I can set this. So you bring the tool forward, watching the needle, and you can see there we're before 0, we're on 0, and we've gone too far. You can see there's quite a bit of retraction, so you can go beyond it. You can tell how far you've gone beyond it. So that's the advantage of a dial indicator, is that it gives you an indication of position before and after the exact 0 point. But one of the disadvantages is it's a little bit more difficult to see in some positions. Now we've got a boring bar dropped down towards the front of center, and we're setting the X. So you can see there how the adjustment is made and what the visibility is like. So in some situations you might be better off using a mirror. A larger faced indicator like the Swiss gyro test equally fits into the tool setter and makes it easier to see. And also the needle is closer to the face, and so you have less parallax error. So that's another approach you could take if you're concerned about high precision and visibility. But the downside of a larger faced indicator is that it's a bigger, bulkier unit and is more obtrusive. There will be some situations, for example this situation, where you've got a tool in a turret and the anvil has to be towards the back, where the turret is blocking off the visibility and making it quite difficult. I want to be clear about all of the pros and cons of these tool setters. I'll set the camera up now so you can see you're sort of peering through a little gap between the tool and the turret. And it's not too bad, but you know, you've got to be prepared for a bit of squinting in some situations. I'll put the camera on a tripod and just show that operating. So I'm just demonstrating where your head might be when you're doing this rather awkward tool setting. And you can see there, setting the tool setter, the X on 0. Well, let's take an example of setting a drill. So we'd set the anvil in its rotary position using the bubble there and the bubble vial. In this case, with the anvil face towards the back, away from us, we'd set the drill. It's really handy to get into the habit of setting the drill so the flutes are in the appropriate alignment, not like that, but like that. Then we could just bring the carriage forward and bring the drill into contact, like so, and set our 0 position. And this is the one case where you don't enter 0 into the touch-off facility. You'd enter the diameter of the drill. You know, if it's an 8.6 drill, in this case I think from memory, you'd enter 8.6 into the tool touch facility. And we'd set the Z by retracting and coming into the end of the anvil. To that position, and enter Z0 in the tool touch facility. So you can see this saves a lot of time with setting your tool offsets. Initially we're doing the mounting and alignment of the tools and then setting your tool offsets. If you'd like to see more demonstrations or illustrations of setting up different shaped tools and how you might set it up in the control software, 2 videos showing the development of the original prototype, I'll put a link in the description. There's quite a few examples there of setting different tools and setting them into the tool touch facility and the tool offsets pages. With the lathe tool setter mechanical with the dial indicator attached, be aware that the dial indicator does not give you an exact metric or imperial measurement, but rather a position. So when you calibrate or set up the lathe tool setter with the needle on 0, the anvil is on X0, but I'll just turn this over so you can see. But because of the ratio change, you're not getting exact metric or inches, but you're just getting an indication of position. So the position is that you're interested in for X and Z is a set place every time. It doesn't matter that those graduations are thous or hundredths of a millimeter. You're just using it as a position, a repeatable position. So in this case I've got a metric dial indicator, but they're not exactly hundredths of a millimeter when you move the anvil with the tool. Well, thanks for watching the video this far. You're still with me and I'm right at the end of the video. You probably need a coffee to follow this next bit, or perhaps I need a coffee to explain it properly. There's various adjustments like the LTS-E, the LTS electronic. There is adjustments to move the anvil and calibrate it so that the surface of the anvil, this surface of the anvil, can be adjusted to split the middle of the tool setter and be on the lathe center line and X0. And it needs to be adjustable. This is quite an important feature to have, and it took me quite a long time to develop it for both the electronic and mechanical tool setters. So we've got the sort of macro adjustment of the dial indicator on its little dovetail rails. We've also got the adjustment of the face, the bezel, is it? The face. You can adjust that. But in addition to that, you really need to have the resting place of the anvil and the position when the surface of the anvil sweeps through the center line through X0, that the needle is adjusted to also sweep past 0 on the dial. I don't know how deeply I should get into explaining this. I'll cover it in the operator's manual video for the owner, but I think you should know that it has got the ability to be adjusted in that direction. So this little adjusting screw that you can see there also positions the resting place of the anvil either before, on center, or after center. So you want it so that it's across center very slightly, and when the tool contacts the anvil, you can see the needles is responding to the tool contacting the anvil. You will need to adjust it so that when the needle strikes 0, that position is X0, is the center line of the lathe, the center line of the tool setter. And it's good to have that adjustment, because otherwise if it was just permanently set from new and it got worn over time, or it got knocked, or you wanted to deliberately offset it for some reason, you wouldn't have the ability to do that. So I had to develop the ability to do that, to have an adjustable anvil position. Well, I should probably wrap up this video on the LTS-M now. Thanks for watching. If you're considering a tool setter, make sure you have a look at the other tool setters, the other two tool setters, the LTS-E and the LTS fixed, the LTS-F, to make sure that you fully understand the range.